While humans acquire language naturally from a very young age, teaching machines to understand and generate human language has been an extraordinary challenge. For decades, this has remained one of AI's most elusive goals. The first breakthrough came with early language models, which had a simple but powerful idea: predict the next word in a sequence, just like how you might guess blue when I say the sky is. These models worked but were limited, struggling with longer contexts and complex meanings. The journey to large language models represents a remarkable evolution in artificial intelligence spanning over 7 decades. It began with simple rule-based systems in the 1950s, where computers followed rigid, predefined rules. The field transformed during the neural network revolution of the 1980s, introducing machine learning models that could learn from data. It wasn't until 2013 that a crucial breakthrough came with word embeddings, which allowed machines to understand relationships between words. The introduction of the transformer architecture in 2017 marked another pivotal moment, setting the foundation for today's powerful language learning models that can engage in natural conversations with humans. The progress we're seeing today stems from advances in deep neural networks. This is a type of AI that uses layers of interconnected nodes, called neurons, to process and learn patterns from data. For example, they power computer vision tasks like image recognition. Language learning models use an architecture called the transformer, an advanced type of deep neural network for language modeling. They are called large because they have billions of parameters. Imagine billions of tiny knobs that can be adjusted to process language using a clever architecture that has been fed vast amounts of text to learn patterns in human language. This allows them to understand and generate human-like text in ways that seemed impossible just a few years ago. Language learning models do this by first converting words into numbers through a process called word embedding to translate words into mathematical representations they can work with. Similar words end up having similar number patterns, helping the model understand the relationship between words. The transformer has two main parts. The encoder breaks down the input text and processes it through multiple layers, each layer getting a deeper understanding of the language. The decoder then uses this understanding to generate appropriate responses. But what makes this system truly powerful is something called attention. When we communicate, we pay attention. We don't just sequence words together randomly. We understand context, meaning, and nuance. When processing the sentence, "the pizza disappeared from the table because it was delicious," the model needs to understand that "it" refers to the pizza and not the table. Attention is like having multiple spotlights that can shine on different parts of a sentence simultaneously. One spotlight might shine brightly on pizza, because food can be delicious, while barely illuminating table, since tables aren't typically described as delicious. Meanwhile, another spotlight might focus on the connection between disappeared and delicious, understanding that something tasty is likely to be eaten and thus disappear. LLMs first learn general knowledge patterns through pre-training on vast amounts of text from sources like books and websites. However, this isn't enough. They need additional fine-tuning on specialized datasets for specific tasks. A key technique, called reinforcement learning from human feedback, involves collecting human feedback for LLM responses. This feedback guides the LLM to generate safe and helpful responses that align with human values. This progress has now allowed us to have conversations with LLMs using natural language through something called prompts. A prompt is the text input that tells the LLM what to do. This has led to an exciting new field called prompt engineering, which focuses on finding effective ways to write prompts to get the most helpful responses from the LLM. These innovations opened up remarkable applications including answering questions, email completion, translating languages, helping with coding, summarizing long documents, and so much more. But perhaps most importantly, they achieved something that once seemed impossible: the ability to engage in meaningful conversations with machines. More recently, LLMs have been transformed into AI agents, intelligent systems that can make decisions and use tools to accomplish real-world tasks while maintaining natural conversations with humans. But remember, while LLMs are incredibly powerful, they're not magic. They learn from human-created data and can sometimes make mistakes or show biases. That's why it's important to use LLMs responsibly, verify important information, be aware of their limitations, and think critically about their outputs. The future of LLMs is exciting. As they continue to improve, they're becoming invaluable tools for creativity, learning, and problem solving.